Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Pythagoras practice questions. If you need any extra help on Pythagoras, if you go to corbettmaths.com/contents and scroll down to video number 257, there's a dedicated video tutorial there on Pythagoras' theorem. Alternatively, you could scan this QR code and it'll bring you straight to that video. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number one. Question number one, it's a non-calculator question, so I'm just putting down my calculator, and it says shown below is a right angle triangle. So we've got this right angle triangle, and we can see it's right angled because it's got this right angle here, and the lengths of the sides are 6 centimeters, 8 centimeters, and the length of the hypotenuse, the longest side of the right angle triangle, is x, because that's opposite the right angle, so this is the hypotenuse. And the question says use Pythagoras' theorem to work out the value of x. So we want to work out the length of this side, x. So let's label our sides. Now remember, Pythagoras' theorem is a squared plus b squared equals c squared. So that's Pythagoras' theorem. And let's label the sides where a and b are the two shorter sides and c is the longest side. So the two shorter sides, now it doesn't actually matter which way around you label these, a and b. I tend to label a which one's the shortest and b the one that's the middle side. So a being the shorter one and b being the one that's a bit bigger. But if I'm not sure, it doesn't actually matter which way around you label them, a and b. But c has got to be the hypotenuse. It's got to be the side opposite the right angle, the longest side of the right angle triangle. So that means that x would be c. Now let's substitute those values into Pythagoras' theorem. So Pythagoras' theorem is a squared plus b squared equals c squared. So let's substitute these values into Pythagoras' theorem. So instead of a squared, actually I'm just going to move this down a bit. So let's just move this to here. And we've got a squared. So a is 6. So we've got 6 squared plus. And then instead of b squared, we've got 8 because b is 8 centimeters. So 8 squared equals c squared. And c is x. So it's going to be x squared. Now it's a non-calculator question, so we now need to work these out. 6 squared, well 6 squared means 6 multiplied by itself. 6 times 6 is 36, so we've got 36 plus, and 8 squared, well that's 8 times 8, and 8 times 8 is 64, so plus 64 equals x squared. So we know that the length of the side squared would be what we get when we do 36 plus 64. So 36 plus 64 is 100. If we add these two together, we get 100, so that's 100 equals x squared. So the length of this side squared is 100. Now this side obviously isn't 100 centimeters, because if this is 6 centimeters and that's 8 centimeters, this wouldn't be 100 centimeters. That's this side squared. So we need to get rid of the squared, so we're going to do the inverse operation, and the inverse to square is square root. And because this is the length of the side, it can't be a negative, so we don't need to worry about that. So we just need to work out the square root of 100. So x equals the square root of 100, just square root in this. And the square root of 100, well what number do we multiply by itself to get 100? Well 10 times 10 is 100, so the square root of 100 is 10. So that means that x equals 10. So that means the length of this side is 10 centimeters, and that's it. So we have used Pythagoras' theorem to work out the length of the hypotenuse, the longest side of this right angle triangle, x, and that's 10 centimeters, and that's it. Okay, let's have a look at our next question, question number 2. So question number 2, it's a calculator question, so that's good. We can pick up our calculator. And we've got this triangle, ABC, and we're told that ABC is a right angle triangle, and we can see from the right angle here that it is. And we're told that AC, the length of this side, is 8 centimeters. That BC, the length of this side, is 15 centimeters. And we've been asked to work out the length of AB, so we want to find the length of this side. So let's label the sides of our triangle. So remember, Pythagoras' theorem is a squared plus b squared equals c squared. And a and b are the two shorter sides, so the two shorter sides of this triangle would be the 8 centimeters and the 15 centimeters, and the longest side of this right angle triangle here would be this AB. Let's just call that x for the minute. So let's label our sides, A being the shortest and B being the middlest, the one in the middle. So now remember, actually it doesn't matter which round you label these. You could label this one B and this one A. I tend to just go A and B, and then the longest side of the right angle triangle would be the hypotenuse, the side opposite the right angle, so the length of this side is C. So that means this side is C if we label it. So let's substitute in our values. So we've got a squared plus b squared equals c squared. So a squared, that's going to be 8 squared, plus b squared, b is 15, so 15 squared is equal to c squared, and that's x, so that's x squared. So we've got 8 squared plus 15 squared equals x squared. Now it's a calculator question, so we can do 8 squared on our calculator, and if we do 8 times 8, that's 64, so 64 plus, and then 15 squared, you can press 15 and then squared on your calculator, and that's equal to 225, and that's equal to x squared. So we've got the length of this side squared would be what we get when we add 64 and 225. And when we do 64 plus 225 in our calculator, we get that's equal to 289. So the length of this side squared is equal to x squared is equal to 289. So let's just turn that around. X squared equals 289. I've just turned those around. Now that's the length of this side squared. We don't want the squared, so we want to do the inverse operation. So we're going to square root 289. So the square root of 289 on our calculator would be equal to 17. So the length of this side would be 17 centimeters. X equals 17 centimeters, and that's it. So the length of AB is 17 centimeters. And let's write that down. It's the x is equal to 17 centimeters. That's it. Okay, let's have a look at our next question. So question number 3. So question number 3, we've got this right angle triangle, ABC, and we're told it's a right angle triangle, and we've got this right angle symbol as well, and we're told that AC is 6 centimeters, that AB is equal to 20 centimeters, and we've been asked to find the length of BC. So we want to find the length of this side. Let's just call that X. Now this question is a bit different than the two we've looked at so far, because the two that we've looked at so far, we've been finding the length of the longest side, the length of the hypotenuse. But this time we've been given that, and we've got one of the shorter sides, and we want to find the other shorter side. So the technique's really the same. We just need to write down what Pythagoras' theorem is. A squared plus B squared equals C squared. Next, we're going to label our sides. So labeling our sides A, B, and C. So A and B are the two shorter sides. So we've got A and B. Now, I think this is going to be the shorter one, so I'm just going to call that A, and B is going to be this one here. You could label them the other way around. It doesn't really matter. But C would have to be the longest side of the right angle triangle, the hypotenuse. It's opposite the right angle, so this is going to be C. So let's substitute in our values. So instead of A squared, we're going to write 6 squared. And then plus, and instead of B squared, we're going to write X squared. What we're trying to find, X squared, is equal to C squared, and C is 20, so that's going to be 20 squared. So this is our equation. We just need to solve it now. So 6 squared is 36 plus, and then we've got X squared is equal to, and we just need to work out 20 squared. It's a calculator question, so 20 times 20 on your calculator, or 20 squared on your calculator, is equal to 400. So we've now got this equation. Now we want to solve this equation, so we don't want this 36 on the left hand side. So remember, whenever we're solving an equation, we want to get x equals. So we want to get rid of this 36, this adding 36, and we want to get rid of the squared. So let's get rid of the 36 to begin with. So let's subtract 36 from both sides of our equation. So on our left hand side of the equation, if we take away 36, well, 36 take away 36 is 0. So we're just going to be left with x squared on the left hand side of the equation. And on the right hand side of the equation, we've got 400 take away 36. And whenever we do 400 take away 36, that's equal to 364. So 364. Now the length of this side obviously isn't 364 centimeters. That's the length of this side squared. We want to get rid of the squared, so we need to do the inverse operation, which will be square root. And remember that this side is the length of a side, so we don't need to worry about any negative solutions. So we're going to square root this. So we're going to get x equals the square root of 364. And we just need to work out what the square root of 364 is. So the square root of 364, and that's equal to 19.07878 and so on centimeters. So that means the length of this side BC is 19.07878 and so on centimeters. Now we've been asked to round our answer to one decimal place. We want to round this to one decimal place, so that'll be 19 point. Now we've got 0.7, so it's going to round up to 1. So it's going to be 19.1 centimeters. So the length of BC is 19.1 centimeters to one decimal place. And that's it. Okay, let's have a look at our next question, question number 4. So question number 4, we've got this right angle triangle, and we've got the lengths of the sides, 3 meters, 9.25 meters, and x meters. And we've been asked to work out the value of x. So we want to find the length of this side of the triangle. So it's a right angle triangle. This is the hypotenuse. So let's label that C, the longest side of the right angle triangle. And let's label the other two sides A and B. And Pythagoras' theorem is A squared plus B squared equals C squared. So let's substitute in our values. So instead of A squared, we've got 3 squared. So 3 squared plus. Instead of B squared, we're going to have x squared because the length of this side is x and it's B. And then instead of C squared, that's going to be 9.25 squared. Now, this is a calculator question, so that's quite nice. We can work this out on our calculator. So 3 squared is 9. So we've got 9 plus x squared equals, and 9.25 squared is equal to 85.5625. So we've got our equation, 9 plus x squared is equal to 85.5625. We now need to solve this equation. So let's take away 9 from both sides of the equation. So we're doing that to just leave us with the x squared on the left hand side. So we'll have x squared is equal to, and if we take away 9, that would give us 76.5625. So we've got x squared is equal to 76.5625. So that's the length of this side squared. Obviously, the length of this side isn't 76.5625 centimeters. That'd be too long. So we now want to get rid of the squared. So we're going to square root. So we're going to get that x is equal to the square root of 76.5625. And when we square root that, we get that's equal to x is equal to 8.75. So that means the length of this side, x is equal to 8.75 meters. And that's it. So the length of this side is 8.75 meters. And that's it. Okay, let's have a look at our next question, question number 5. So question number 5, we've got a right angle triangle. It's a non-calculator question, so I'm just putting down my calculator. And it says, shown below is a right angle triangle, CDE. And it's right angled. We can see the right angle symbol there. And we've been asked to work out the length of CE, the length of this side. Let's just call it x. So we want to find the length of that side. So let's write down Pythagoras' theorem. So we've got a squared plus b squared equals c squared. And let's label the sides. So we've got the two shorter sides here. Let's label that one A and that one B. Again, you can do it the way around if you wish. And the longest side of the right angle triangle will be C. So, and that's obviously opposite the right angle. So this side is C, the longest side of the right angle triangle. So we've got Pythagoras' theorem. Now let's substitute in our values. So instead of A squared, it's going to be x squared plus, and instead of b squared, it's going to be 12 squared. And instead of c squared, it's going to be 13 squared. So we've got x squared plus 12 squared is equal to 13 squared. So that's x squared plus, now 12 squared, well 12 times 12 is 144. And then we've got that's equal to 13 squared. Now 13 times 13 is 169 if you know that off by heart. Alternatively, we could work it out. So 13 multiplied by 13. So 3 times 3 is 9. And 3 times 1 is equal to 3. So we've multiplied 13 by 3, and we've got that's equal to 39. Now we need to do 13 times 10. So put our 0 down. 1 times 3 is 3. 1 times 1 is 1. And then just add them up. 9 plus 0 is 9. 3 plus 3 is 6. And then we've got 1. So whenever we do 13, multiply by itself, 13 squared, we get that's equal to 169. So we've got the x squared plus 144 is equal to 169. So we're going to take away 144 from both sides of the equation to just leave us with our x squared on the left-hand side. So we've got x squared is equal to, now 169 take away 144 would be equal to 25. And again, you could do your column method of subtraction if you wished here. So you could do 9 take away 4 is equal to 5, 6 take away 4 is equal to 2, and 1 take away 1 is equal to 0. So that's 25. Now the length of this side obviously isn't 25 centimeters. That's too large. That's this side squared. So we need to square root. So we're going to get that x is equal to the square root of 25. And the square root of 25, well, 5 times 5 is 25. So the square root of 25 is 5. So x is equal to 5. So the length of this side is 5 centimeters. And that's it. Okay, let's have a look at question number 6. So question number 6 is a calculator question. So great, I can pick up my calculator again. And we've got this right angle triangle, ABC, with a little right angle here. And we're told that AC is 7 centimeters, BC is 24 centimeters. And we've been asked to work out the length of AB. So let's label the sides of our triangle. So the smaller side, A, and B, the two shorter sides. And again, you can label those the way around if you wish. And the largest side of the right angle triangle, let's call that X, and that's going to be C, the longest side of the right angle triangle, opposite the right angle. So let's write down Pythagoras' theorem. A squared plus b squared is equal to c squared. And let's substitute in our values. So instead of a squared, it's going to be 7 squared plus, and instead of b squared, it's going to be 24 squared. And that's equal to c squared. That's going to be x squared. Now let's work this out. So we've got 7 squared, and it's a calculator question. 7 times 7 is 49. We should know that anyway. Plus 24 squared. So I'm going to do it on my calculator. For some reason, I'm thinking it's 576. Let's check. Yeah, 576. And that's equal to x squared. Now we need to work out what this is. So 49 plus 576 is equal to 625, and that's equal to x squared. Now this side obviously isn't 625 centimeters, so we need to get rid of the squared by square rooting. So x is equal to the square root of 625, and if we square root 625, that's equal to 25. So x is equal to 25 centimeters. So that means the length of AB is 25 centimeters, and let's write that down, 25. And that's it. Okay, let's have a look at question number 7. So question number 7 says, shown as a right angle triangle. So we've got this right angle triangle, and the height of it is 7 centimeters, and the base of it is 10 centimeters. And we've been asked to work out the perimeter of the triangle and to give our answer to 1 decimal place. So we want to find the perimeter, and remember, to find the perimeter of a shape, we add up around the outside of the shape. So we want to add up the length of the 3 sides of the triangle. Now we know 2 of them, 7 plus 10 is equal to 17 centimeters. So the distance from here to here is 17 centimeters. We need to work out this distance as well, so we can then add that on to find the whole perimeter of the triangle. So we need to find the length of this side, and we're going to use Pythagoras' theorem to do that. So let's label the sides of the triangle A, B, and C, and I'm just going to call that side X to begin with. So we've got A is 7 centimeters, B is 10 centimeters, and C is X. You could label these the way around again if you wish. And let's write down Pythagoras' theorem. A squared plus B squared is equal to C squared. So A squared, that's going to be 7 squared, plus B squared, that's going to be 10 squared, is equal to C squared, and that's going to be X squared. 7 squared, that's 49, plus 10 squared, that's 100, 10 times 10 is 100, is equal to X squared. And then 49 plus 100 would be 149, and that's equal to X squared. And let's just turn that around. X squared is equal to 149. Now again, this side obviously is 149 centimeters. That's the length of this side squared, so we need to square root. So X is equal to the square root of 149, and that's equal to, if we press the square root of 149, that's equal to 12.20655 and so on. So that's the length of this side, 12.20655 and so on. So that's great. We now know the lengths of the three sides of the triangle, and we can add them up to find the perimeter of the triangle, because if we start here, we could do 7 plus 10 plus 12.20655 and so on. So let's write that down. 7 plus 10 plus 12.20655 and so on. And I'm just going to do it on my calculator. Now I've got this on my calculator display already, so I can just press plus and then 7 plus 10, and that's equal to, and it's come up as 17 plus the square root of 149. So if I change that into a decimal, I get that's equal to 29.2065562 and so on. And we've been asked to give our answer to one decimal place, so that would be 29.2 centimeters to one decimal place, because obviously it's 2 zeros, so we're not going to round up, so it's going to be 29.2 centimeters. So the perimeter of this right angle triangle to one decimal place would be 29.2 centimeters. The distance around the outside of it to one decimal place is 29.2 centimeters. Okay, let's look at our next question, question number 8. So question number 8, we've got this triangle, and we've got the length of this side, the longest side of the triangle, the hypotenuse is opposite the right angle, is 40 centimeters. The length of the height, or the height of the triangle, is 9 centimeters, and the length of the base is X centimeters. And Charlie says that the length of the missing side is 41 centimeters. Now, I know that's wrong straight away. Because it's a right angle triangle, the longest side is opposite the right angle, and if the longest side is 40 centimeters, the missing side, this one, couldn't be 41 centimeters. This side cannot be longer than this side. So he must have made a mistake. It says here's his method, so that's great. We can see, hopefully where he's made the mistake, and we've been asked to explain his mistake. So let's look at our triangle. Let's label the sides. So if I was doing this question, I would label this one A and B, and remember I could label them the way around if I wanted to. I could call this one B and this one A, but this one would have to be C, the longest side of the right angle triangle. And Pythagoras' theorem is A squared plus B squared equals C squared. Now if we substitute in these values, we'd have A squared, that's going to be 9 squared, plus, and instead of B squared we'd have X squared, and that's equal to the longest side squared, which is 40 squared, so 40 squared. Now let's have a look and see what he's done. He's written Pythagoras' theorem, that's right. Now if we have a look at his next line, he's got 9 squared plus 40 squared is equal to X squared. Well, he's saying that the longest side is X, but the longest side of the triangle would be 40. The 40 would have to go here. If we look at it, we've got 9 squared. Yes, that bit's right, 9 squared. And then we've got plus X squared. He's labelled them the wrong way around. He's put them in the wrong positions. He's actually said that this is one of the shorter sides, and he's saying this is the longest side of the triangle. So Charlie's labelled his sides wrong, or he's put his values into the wrong place in Pythagoras' theorem. So let's write that down. And that's it. So I've just written down that Charlie should have used 9 squared plus X squared equals 40 squared, not 9 squared plus 40 squared equals X squared, that he's substituted them into the wrong positions. And that's it. Okay, let's have a look at our next question. So question number 9, we've got this triangle, and we've got the height of the triangle is 10 centimeters. The length of the hypotenuse, the side opposite the right angle, is 14 centimeters, and we've got the base, which we don't know. Let's just call that X. And we've been told that it's a right angle triangle, and as you can see, it's a right angle triangle, and we've been asked to calculate the area of the triangle. So to find the area for the triangle, so to calculate the area of a triangle, we do the area is equal to half the base times the height. That's how you find the area of a triangle. You do the base multiplied by the height divided by 2, or half the base times the height. So we need to know the base of this triangle, the length of the base, because if we know the length of the base, we can do half the base times the height, or the base times the height and then half it, and get the area of the triangle. So we need to find the length of this side, and we're going to use Pythagoras' theorem. So a squared plus b squared equals c squared. So that's Pythagoras' theorem, and let's label the sides. Now in terms of the a and b, I'm not entirely sure which one's the shortest, so I'm just going to call them a and b, and remember it doesn't matter which way around, but c would have to be the 14 centimeters. And let's substitute those into Pythagoras' theorem. So a squared, that's going to be 10 squared, plus b squared, that's going to be x squared, is equal to c squared, and that's going to be 14 squared. And then we've got 10 squared, 10 times 10 is 100, plus x squared is equal to 14 squared. So we can do 14 squared in our calculator, and that's equal to 196. Now we want to find out what x is, so we want to get rid of the 100, and then we want to get rid of the squared. So let's take away 100 and take away 100. And on our left hand side we'd have x squared, and on the right hand side we had 196. We're taking away 100, so we'd just be left with 96. So that means that the length of the base squared is 96. We don't want it squared, we just want to find out what x is, so we need to square root. So x is equal to the square root of 96. And if we do the square root of 96, the square root of 96, that's equal to 4 root 6, or as a decimal number, that would be equal to 9.797958971 and so on centimeters. So that's the length for the base, 9.7979 and so on. Now I'm not going to round that because we need to use that now to find the area for the triangle. So the area for triangle, area is equal to, so a half multiplied by the base, which is equal to 9.79795897 and so on, and then multiplied by half the base times the height, and the height's equal to 10. So I'm doing half the base multiplied by the height. And we just need to type this into our calculator, so we need to press a half, so the fraction button, a half, or you could do 0.5 multiplied by, and I've already got this as my answer, so I can just press the answer key, or you could type in 9.79795897 and so on, and then multiply by 10, and that's equal to 48.98979 and so on. And that's the area of the triangle, so that's centimeters squared. And that's it. And let's just round that to 2 decimal places. So that'll be 48 point, and then we've got 0.989. So let's round that to 2 decimal places. So that'll be 0.99 centimeters squared. So the area of that triangle is 48.99 centimeters squared. And that's it. So just to recap, with that triangle, we didn't know the length of the base. We used Pythagoras to get the length of the base, which was 9.7979 and so on. And then we just done the base times the height divided by 2, or half the base times the height, and that gives the area of the triangle. And that's it. Okay, let's have a look at question number 10. Okay, question number 10. So in question number 10, we've got this diagram, and it says not drawn to scale, and we've got a wall and the ground, and you couldn't have a set of Pythagoras questions without a ladder and a wall question involved. So we've got this wall and this ground here, and we've got this ladder, and a 4-meter ladder, so that's a 4-meter ladder, is placed against a vertical wall. The base of the ladder is 1.5 meters from the base of the wall, so that means that's the bottom of the ladder, that's the bottom of the wall, and the distance is 1.5 meters. This ladder might not be safe, so don't try this one at home, and just think it's quite far out from the base of the wall, and it says work out how far the ladder reaches up the wall. So what we want to do is we want to find the distance from here to here. We want to find the length of this side of the triangle. So if we have a look, we can ignore this part, and we've got this right angle triangle, and the longest side of the right angle triangle would be our 4 meters. Let's call that C, the longest side of the right angle triangle, and then we've got our 2 shorter sides, and I'm just going to call this one A and this one B, and again you could do them the way around if you wished. So Pythagoras' theorem is a squared plus b squared equals c squared. And if we substitute our values, instead of a squared, we've got 1.5 squared. I'm just going to call this x for the moment, the height up the wall that the ladder reaches. So plus, and then instead of b squared, I'm going to write x squared is equal to c squared, and that's going to be 4 squared. Now, this is a calculator question, so we can do 1.5 squared on our calculator, and that's 2.25. Plus, and then we've still got x squared, and that's equal to 4 squared, and that's equal to 16. So we've got 2.25 plus x squared is equal to 16. Now we want to find out what x is, so we want to get rid of this 2.25, and then we're going to get rid of the squared. So let's take away 2.25 from both sides of the equation. So take away 2.25 from the left hand side and the right hand side. So on the left hand side of our equation, well, we're taking away 2.25 to get rid of the 2.25, so we'll just be left with x squared. And on the right hand side we had 16, we're taking away 2.25, so that would leave us 13.75. So that means that x squared is equal to 13.75. Now we want to find the square root of that, so we're going to do the square root of that. So x is equal to the square root of 13.75, and that means that x would be equal to, if we square root that, we get an answer of 3.708099 and so on meters. So how far does the ladder reach up the wall? Well, that would be 3.7 meters to one decimal place. So it would be x is equal to 3.7 meters to one decimal place, to 1 dp, and that's it. So the height the ladder reaches up the wall will be 3.7 meters, so from here to here, and that's it. So we just use Pythagoras' theorem to find the length of the shorter side, and that's it. Okay, let's have a look at our next question, question number 10. So we've got this right angle triangle, RST, and we've got some measurements. We know that RS is 50 centimeters and ST is equal to 2 meters. We've been asked to find the length of RT and to give our answer in meters. Now, the first thing that I notice in this question is, well, one, the triangle looks upside down, but it's still a right angle triangle, and the longest side would be the 2 meters. It's opposite the right angle, so that's the hypotenuse. The other thing that I notice is the units on the sides. One's in centimeters and one's in meters, and whenever you're doing a Pythagoras question, you want to be having the same units on the sides. You want the same measurements. So if you're dealing with centimeters on one side, deal with centimeters on the other, or meters and meters, and so on. Now the question says to give our answer in meters. So what I'm going to do is I'm going to change this centimeters, the length of RS, into meters. So 1 meter is equal to 100 centimeters. So if we divide this by 100, we can find what it would be in meters. So 50 divided by 100 would be equal to 0.5. So 50 centimeters is half a meter, or 0.5 meters. So that means that RS is 0.5 meters. So we've now got our measurements that RS is 0.5 meters, that ST is equal to 2 meters, and we want to find the length of RT. So let's call that x. And let's write down Pythagoras' theorem that a squared plus b squared is equal to c squared. So we've written down Pythagoras' theorem. Now let's label our sides. So A and B are the two shorter sides. I'm going to call this one A and this side B, and then the longest side of the right angle triangle would have to be this side, which is C, or 2 meters. And let's substitute in our values. So A squared, that's going to be 0.5 squared, plus B squared, well, B's x, that's x squared, is equal to C squared, and C is equal to 2 meters, so that's going to be 2 squared. Now 0.5 squared, as a calculator question, would be 0.25 plus x squared, well, that's x squared, is equal to 2 squared. 2 times 2 is equal to 4. Now we know that 0.25 plus x squared is equal to 4. We want to get the x on its own, so we want to get rid of this 0.25, and then we want to get rid of the squared. So let's take away 0.25 from both sides of our equation. And if we take away from the left-hand side, we'd just be left with x squared. And on the right-hand side, we had 4. Take away 0.25 would be 3.75. So that means the length of this side squared is 3.75, but we don't want that. We want to find out what x is, so we need to square root. So the square root of 3.75. And if we work out the square root of 3.75, so the square root of 3.75, that's equal to 1.93649 and so on meters, and that's it. So the length of this side, RT, is equal to 1.93649 and so on meters. Now I've been asked to give our answer to one decimal place, so we want to round this to one decimal place. So it's 1.93, so we're not going to round up, so it's going to be 1.9 meters to one decimal place. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 12. So question number 12 says, Belinda sketches the triangle below. So she sketches this triangle, and it says not drawn accurately, so she's just done a quick sketch, but the length of the side should be 4.5 centimeters, 2.8 centimeters, and 5.3 centimeters. And the question says, show that the triangle is right angled. So we want to show that this triangle should be a right angle triangle. And if it is a right angle triangle, Pythagoras' theorem should work, or will work. If Pythagoras' theorem doesn't work, the triangle wouldn't be right angled. So let's write down what Pythagoras' theorem is. It's a squared plus b squared equals c squared. So if we work out what a squared plus b squared is, and we work out what c squared is, if they're equal to each other, then the triangle will be right angled. So let's label the sides of the triangle. So the two shorter sides, well, a and b are going to be the two shorter sides. That's the 2.8 centimeters and the 4.5 centimeters. And the length of the longest side of the triangle is 5.3 centimeters. So let's call that c. So we've got what a and b are and c are. So let's work out what a squared plus b squared is. So a squared plus b squared, that's going to be 2.8 squared plus b squared, which is 4.5 squared. And let's see what we get. So whenever we do 2.8 squared plus 4.5 squared, that's equal to 28.09. So that means that a squared plus b squared is equal to 28.09. And if we work out what c squared is, so c squared, that's going to be 5.3 squared. And that's equal to, if we do 5.3 squared, that's equal to 28.09. So we've got that a squared plus b squared is equal to c squared. So a squared plus b squared is equal to c squared, because 28.09 is equal to 28.09. So that means that Pythagoras' theorem works. So because Pythagoras' theorem works, it is a right angle triangle, or it should be drawn as a right angle triangle with those measurements. And that's it. So let's write that down. And that's it. So I've written down, as Pythagoras' theorem is satisfied, or as Pythagoras' theorem works, the triangle is right angled. So that's it. Okay, let's have a look at our next question, question number 13. So question number 13 says, Nicole draws a triangle. This is a non-calculator question, so I'm putting down my calculator. And she draws a triangle, and the lengths of the sides are 4 centimeters, 6 centimeters, and 7 centimeters. And the question says, is the triangle a right angle triangle? So this is very similar to question number 12. And to show if a triangle is right angled, we want to show that Pythagoras' theorem would work. And if it's not right angled, then Pythagoras' theorem wouldn't work, or wouldn't be satisfied. So let's write down Pythagoras' theorem. So that's a squared plus b squared is equal to c squared. And let's label the sides. So the two shorter sides are a and b, and the longer side would be c. So let's work out what a squared plus b squared would be. So a squared plus b squared, so that would be 4 squared plus 6 squared. And 4 squared is 16, plus 6 squared is equal to 36, and 16 plus 36 is equal to 52. So a squared plus b squared is equal to 52. Now that will have to be equal to c squared if it's a right angle triangle. So let's work out what c squared is. So c is 7, so c squared would be 7 squared, and 7 squared is equal to 49. So that means that a squared plus b squared is 52, and c squared is equal to 49. So they're not equal to each other. 52 is not equal to 49. So that means that a squared plus b squared is not equal to c squared. So that means the Pythagoras' theorem doesn't work. So that means the triangle is not a right angle triangle. So let's write that down. And that's it. So I've written down, as Pythagoras' theorem is not satisfied, the triangle is not right angled, because Pythagoras' theorem doesn't work whenever we substitute in the numbers. It's not a right angle triangle. Okay, let's look at our next question, question number 14. Okay, let's have a look at our next question, question number 14. So question number 14, we're told the distance from a point on the ground to the base of a tree is 18 meters. So from this point on the ground to the base of the tree is 18 meters. And the distance from a point on the ground to the top of the tree, so directly from here to the top of the tree, is exactly 20 meters. And the question says, calculate the height of the tree. So we want to calculate the height of this tree. So we've got a right angle triangle. If we have a look here, we've got, there's the height of the tree. So from the base of the tree up to the highest point. That's a right angle triangle. We know that distance is 18 meters. We know the distance from the top of the tree to the ground there is 20 meters, and we want to find here the height of the tree, x. So that's a right angle triangle, so we can use Pythagoras' theorem. So a squared plus b squared is equal to c squared. So let's label our sides. A and b are the two shorter sides, and c is the hypotenuse, the longer side. So the c is going to be our 20 meters, the longest side of the right angle triangle. And the a and the b, I'm going to call this side a and this side b. So we've got a is x, we've got b is equal to 18 meters, and c is equal to 20 meters. So let's substitute those into Pythagoras' theorem. So a squared, that's going to be x squared, plus b squared, that's going to be 18 squared, is equal to c squared, and that's going to be 20 squared. Let's now work this out, and it's a calculator question, so that's quite nice. We can work out what 18 squared is. So 18 squared is equal to 324. So we've got x squared plus 324 is equal to 20 squared, and 20 times 20 is 400. So we've got the x squared plus 324 is equal to 400. Now let's subtract 324 from both sides of our equation. So we're going to be left with x squared is equal to, and when we do 400, take away 324, that's equal to 76. So the height of the tree squared is 76. Obviously it's not 76 meters. So we now need to square root that to find the height of the tree. So x is equal to the square root of 76. And when we work out the square root of 76, the square root of 76, that's equal to, x is equal to 8.717797, and so on, meters. So that means the height of the tree is 8.7 meters to one decimal place, and that's it. Okay, let's have a look at our next question, question number 15. So question number 15 says, shown below is a rectangle. So we've got this rectangle. The length of the rectangle is 20 centimeters. The height of the rectangle, or the width of the rectangle, is 7 centimeters. And we've been asked to work out the length of the diagonal x. So we want to find the length of the diagonal of the rectangle. So we want to find this distance from here to here. Now, because it's a rectangle, that means that's a right angle there in the corner. So we've got a right angle triangle. So if we use Pythagoras' theorem, we can find the length of this side. So this is our right angle. So the side opposite it would be the hypotenuse. So x is going to be the hypotenuse. So let's label that c. And a and b are our two shorter sides, so a and b. And Pythagoras' theorem is a squared plus b squared is equal to c squared. So let's substitute in our values. So a squared, that's going to be 7 squared, plus b squared, that's going to be 20 squared, is equal to c squared, and that's going to be x squared. So now let's work this out. So we've got 7 squared, 7 times 7 is 49, plus 20 squared, that's going to be 400, is equal to x squared. 49 plus 400 is 449, and that's equal to x squared. This side obviously isn't 449 centimeters, so we now need to square root that. So we're going to get that, and let's just actually turn around to begin with. X squared is equal to 449. So we're going to get that x is equal to the square root of 449, and that's equal to 21.1896201. And let's just write that to 2 decimal places. That'll be 21 point, and we've got 189, so we'd round up to 21.19 centimeters. So the length of the diagonal of this rectangle would be 21.19 centimeters to 2 decimal places, and that's it. Okay, let's look at our next question, question number 16. Okay, let's have a look at our next question, question number 16. And we've got another rectangle, and actually whenever we're using Pythagoras, sometimes in questions you'll see rectangles involved because quite often you can cut them across into diagonally into right angles. So we've got this rectangle, ABCD, and we're told that AD is 5 centimeters. We're told that BD, the length of the diagonal of the rectangle, is 13 centimeters. I've been asked to calculate the area of rectangle ABCD. So we want to find the area of the rectangle. So if we know the width of the rectangle, this AD is 5 centimeters. If we can find the length of it, we can do the length times the width to find the area of the rectangle ABCD. So we need to find this distance here. Let's call that x. And if you notice, we've got our right angle because it's a rectangle, and we've got our right angle triangle because we've cut across diagonally. This would be a right angle. So we've got this right angle triangle, and we've got the shorter side here is 5 centimeters. We've got another shorter side is x, and our hypotenuse, the longest side of the right angle triangle, would be our 13 centimeters. So let's label our sides C, the longest side of the right angle triangle. We've got our 2 shorter sides A and B. And let's write down Pythagoras' theorem. So that's A squared plus B squared is equal to C squared. So let's substitute our values. So A squared, that's going to be 5 squared, plus B squared, that's going to be x squared, is equal to C squared, and that's going to be 13 squared. 5 squared, 5 times 5 is 25, so we've got 25 plus x squared, that's going to be x squared, is equal to 13 squared, and 13 times 13 is 169. So we've got the 25 plus x squared is equal to 169. This is an uncalculator question, so we want to find what this is. We want to solve this equation now, obviously without using a calculator. So let's take away 25 and take away 25, and that will give us on our left-hand side of our equation, we'll just be left with x squared, and on our right-hand side we'll have 169. Take away 25, that's 144. So we've got the x squared is equal to 144. If we square root that, we can find out what x is. So x is equal to the square root of 144. And the square root of 144 is 12. So x is equal to 12 centimeters. So if we go back up to our rectangle, we've now got the x, the length of this AB, this side here is 12 centimeters. So let's write that down, 12 centimeters. So in terms of our rectangle, the area of the rectangle will be the length multiplied by the width. The length of the rectangle is 12. The width of the rectangle is 5. So we're going to do the area is equal to 12 multiplied by 5, and 12 times 5 is equal to 60 centimeters squared. So the area of rectangle ABCD is 60 centimeters squared, or 60 square centimeters, and that's it, so 60. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 17. So question number 17 says ABC is an isosceles triangle. So we've got this isosceles triangle, and we're told that AB equals BC equals 8 centimeters. So the length of the right hand side is equal to the length of the left hand side, and they are 8 centimeters each. And the length of the base, so from A to C, is 5 centimeters. And we've been asked to calculate the height of the triangle, so the length of this height, or the height of the triangle H. So if you'll notice, if we chop this triangle in half, so straight down through the middle, then you'd have a right angle triangle on the right hand side and a right angle triangle on the left hand side. Now let's focus on this right angle triangle on the right hand side here. We've got the hypotenuse, the longest side of this right angle triangle is 8 centimeters. We're trying to find this height here, and in terms of this distance from the middle of AC to C would be 2.5 centimeters. Because we're chopping the isosceles triangle in half, it's got a line of symmetry through the middle, so that'll be 2.5 centimeters on the right hand side and 2.5 centimeters on the hand side. And we've been asked to find the height of the triangle. So we just need to use Pythagoras' theorem. We've got this right angle triangle, so let's label our sides. A and B are the 2 shorter sides. I'm going to call this one A and this one B, and the longest side of the right angle triangle will be our C. So we've got our A, B and C, and let's write down Pythagoras' theorem. A squared plus B squared is equal to C squared. So A squared, that's going to be 2.5 squared, plus B squared, that's going to be H squared, is equal to C squared, and that's going to be 8 squared. Now 2.5 squared, well 2.5 squared is equal to 6.25. We've got 6.25 plus h squared is equal to 8 squared, and 8 times 8 is 64, so 64. Now we want to find out what h is, so let's get rid of this 6.25. So let's take away 6.25 from both sides of our equation. So we're going to be left with, on the right hand side, h squared, and on the right hand side we've got 64, take away 6.25, and that's equal to 57.75. Now that's h squared. We want to find just what h is, so we want to get rid of the squared, so we're going to square root. So h is equal to the square root of 57.75, and if we square root 57.75, we'll find the height of this triangle, the height of this isosceles triangle. So the square root of 57.75 is equal to 7.59934, and so on, centimeters. And we can just round that. Let's round that to 3 decimal places. That'll be 7.599 centimeters to 3 decimal places. And that's it. So the height of our isosceles triangle will be 7.599 centimeters to 3 decimal places. Okay, let's have a look at our next question. So our next question, a helicopter is flying from Redville to Leek, and the helicopter departs Redville. So let's put our cross for Redville. So that's Redville. Let's just call that R for the minute. It flies 60 miles west. So it goes 60 miles west. So if we call this north, east, south, and west, and we let that be north. So west is going to be to the left here. So we're going to go 60 miles west. So that way. So let's go 60 miles straight west. So 60 miles. And then the helicopter flies 25 miles north. So it flies 25 miles north and it arrives in Leek. So that means that Leek is here, L, and it flies 25 miles north. So the helicopter leaves Redville, goes 60 miles west, 25 miles north, and it arrives at Leek. And the question says, work out the direct distance of Leek from Redville. So we want to find this direct distance. Let's actually just use our ruler and pencil, and let's mark in that distance. So we want to find that direct distance from Redville to Leek. So if you'll notice, that's a right angle triangle, because if we go west and then we go north, that's going to be a right angle. And let's label our sides, A and B being the 2 shorter sides, and C being the longer side of the right angle triangle, that hypotenuse. So let's just call that X here. So we've got the a squared plus b squared is equal to c squared. A and b are 2 shorter sides, so it's going to be 25 squared plus 60 squared is equal to x, the distance between our 2 towns, the direct distance, which would be x squared. 25 squared, that's 625, plus 60 squared, that's going to be 3,600. And remember, this is a calculator question, so you can work those out, is equal to x squared. 625 plus 3,600 would be 4,225, and that's equal to x squared. Now, we don't want to know the distance squared, we want to find the distance, so we need to square root it. So x is equal to the square root of 4,225, and when we do the square root of 4,225, that's equal to 65. So x is equal to 65, so that's 65 miles. So the direct distance from Redville to Leek is 65 miles. So if the helicopter could have just flown directly to Leek from Redville directly, that would have been a 65-mile journey, just going directly between them. Okay, let's have a look at our next question, question number 19. Okay, let's have a look at our next question, question number 19. So question number 19 says a line joins the points L, which is -3, 2, and M, which is 1, -3. So this line joins those 2 points, and we've been asked to work out the length of that line, LM. So we want to find the length of that line joining those 2 points, or the distance between those 2 points. And whenever you're dealing with coordinates and you're trying to find the distance between 2 points, you'll often use Pythagoras' theorem. So we've got this point L, and if you go across, if we go across from L all the way here to just above M, you can see we've gone from -3 to 1. So we've gone 4 across. So we've gone 4 across, and just be careful, I'm not counting the number of boxes I've gone across, I'm looking at the numbers. I'm going from -3 to 1, so I'm going 4 across. The reason I'm not counting the boxes is sometimes the boxes might go, for instance, 0, 2, 4, 6, 8, and so on, and you want to see, you know, in terms of the numbers, how far you're going across. You're not counting the number of little boxes. And then in terms of the height, we're going from a height of 2, and we're going down to -3. And if we've got a height of 2 and we go down to -3, we're going 5 down. Now again, in this particular question, I could count the boxes, because with the scales are, you know, we're going across in ones and ups and ones, and that's 1, 2, 3, 4, 5 down. So we've gone 4 across and 5 down. So that works in this question. But if the vertical scale, for instance, went up in 5s and went 5, 10, 15, 20, and -5, -10, -15, -20, and so on, you would need to look at the numbers and see, well, you're going from a height of perhaps 10 10 down to a height of perhaps some negative 15. So it's going to be 25 in terms of the height of that triangle. So you're not counting the boxes, you're looking at the numbers. And in this case, we went from negative 3 to 1. So we've gone 4 across, and we've gone from a height of 2 down to a height of negative 3, and that's 5 down. But in this case, because the boxes each represent 1, the scale is 1, we could count the number of boxes and so on. So here we've got this triangle, and it's a right angle triangle, and the measurements of the two shorter sides are 4 and 5 units. I'm not calling them centimeters because it doesn't say anything about a centimeter grid. It's just, so in this case, I'm just calling them units. I don't know what the measurements are, so we'll just call them units. And it says work out the length of the line LM. So we want to find the length of this line, so we want to use Pythagoras' theorem. So let's label our sides. So I'm going to call our two shorter sides A and B, and the length of the longest side C. And let's write down Pythagoras' theorem: A squared plus B squared equals C squared. So A squared, that's going to be 4 squared, plus B squared, that's going to be 5 squared, and that's equal to C squared. And I'm just going to call that, well, let's just call it C squared. 4 squared, 4 times 4 is equal to 16. 5 squared is 5 times 5, that's 25, and that's equal to C squared. 16 plus 25 is 41, so 41 equals C squared. So the length of this side squared is 41. We want to find just the length of the side, so we need to square root. So C squared is equal to 41. So C is equal to the square root of 41. And the square root of 41, if we work it out, the square root of 41 is equal to 6.403124 and so on. And we've been asked to give our answer to 3 decimal places, so that'll be 6.403 units, and that's it. So the length of that line, LM, the length of this line is 6.403 to 3 decimal places, and that's it. Okay, let's have a look at our next question. Question number 20. So question number 20 says, a councillor designing a dog park, so it's a dog park, that it'll be a rectangular field. So we've got this rectangular field. The field's going to be, the length of the field is twice the width of the field. So the length of the field is twice the width. Well, if the width is 70 meters, 70 multiplied by 2 is equal to 140 meters. So that means that the length of the field is equal to 140 meters. Then we're told the field will be divided by a wall into 2 sections. So this field is going to be divided into 2 sections, one for the large dogs and one for the small dogs. And we've been asked to work out the length of the wall dividing the 2 sections. So we want to find the length of the wall. So this is the wall that divides the 2 sections here. So this is the wall, and we want to find the length of that wall. So that's what we want to find. So let's call that X. Now if we have a look at the small dog section, that's actually a right angle triangle, because that's a right angle. As you can see, it's a triangle. And we know that one of the lengths of the sides is 70 meters. And actually, we're trying to find the length of this side, but so it would be useful if we had the length of this side of the triangle. Now we know that the whole length of the dog park is 140 meters. So if we take away 60, so 140 take away 60, that's equal to 80 meters. So that means that this distance is 80 meters. So that means that we've got the length of 2 sides of our right angle triangle, so we can use Pythagoras' theorem to find the length of the third, the length of the wall, X. So let's do that. So let's label our sides A, B and C is the longest one opposite the right angle. So let's write down Pythagoras' theorem. So Pythagoras' theorem is A squared plus B squared is equal to C squared. A squared, that's going to be 70 squared, plus B squared, that's going to be 80 squared, is equal to C squared, and I'm just going to call that X squared. 70 squared, well, 70 times 70, it's a calculator question, 4,900, plus 80 squared, that's going to be 80 times 80, 6,400, is equal to X squared. 4,900 plus 6,400 is equal to 11,300, and that's equal to X squared. So that's the length of the wall squared, so we want to square root, so let's just turn it around. X squared is equal to 11,300, so that means that X is equal to the square root of 11,300, and if we do that, we'll find the length of the wall. So the square root of 11,300 is equal to 106.301 and so on meters. And let's just round that to 1 decimal place. That is 106.3 meters to 1 decimal place, to 1 dp. So that means the length of the wall dividing the large dogs from the small dogs would be 106.3 meters to 1 decimal place. And that's it. Okay, let's have a look at question number 21. So question number 21 says, below are 2 triangles, ABC and BCD. So we've got ABC, that's a right angle triangle, and BCD, that's also a right angle triangle. So we've got these 2 right angle triangles, and the question says, find the length of BD. So we want to find the length of BD, which is labelled X. So we want to find the length of this side of the triangle, this distance here joining B to D. Now, if you have a look at this triangle BCD, we've only got the length of one side, so we're not going to be able to use Pythagoras' theorem. But if we have a look at this triangle at the bottom, ABC, we've got the length of two sides. We know that AC is 6 centimeters and the AB is 7 centimeters, so we could use Pythagoras' theorem to find the length of BC. And then, once we find the length of BC, we can use Pythagoras' theorem again to find the length of BD, the x. So let's do that. So let's look at this triangle to begin with, and I'm actually going to use blue ink to begin with here. So I'm going to label the sides, so the two shorter sides, A and B, and the longer side, the hypotenuse of this smaller right angle triangle will be here, so let's call that C. And let's write down Pythagoras' theorem, A squared plus B squared equals C squared. So it's going to be A squared, that's 6 squared, plus B squared, that's 7 squared, is equal to C squared. I'm just going to call that Y for the moment, so that's going to be Y squared. So 6 squared is 36, plus 7 squared, that's 49, is equal to Y squared. And 36 plus 49 is equal to 85. So 85 equals Y squared. And if we turn that around, we get Y squared is equal to 85. That's the length of this side squared, so we need to square it. So Y is equal to the square root of 85, and the square root of 85 is equal to, 9.2195 and so on centimeters. So that's the length of this side. Now actually in this question I could use that number, that 9.2195 and so on centimeters, or I could just use the square root of 85, and that actually can be quite useful in a question like this, because if we need to use Pythagoras' theorem again, like we do, if I use this number, this 9.2195 and so on, and I round it, and then I square it and stuff again, what I'm going to do is I'm going to be sort of bringing in a bit of an error into my answer. So if I could just leave it as this root 85 for the minute, that can actually be quite useful. So I'm actually going to write beside this length of BC, the square root of 85, and I'm going to use that because that's going to be quite useful. So now let's change color of ink to red, and now let's focus on this triangle BCD. So this is a right angle triangle, and let's label the sides. So the two shorter sides, A and B, and the longest side, which is opposite the right angle, will be our x. Let's call that C. And let's write down Pythagoras' theorem, A squared plus B squared equals C squared. So A squared, that's going to be the square root of 85, and I'm just going to put that in brackets, squared, plus B squared, which is 11 squared, is equal to C squared, which is x squared. Now here you could, instead of writing the square root of 85, you could have written 9.2195 blah 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 and written that all out and squared, and that's totally fine if you want to, but try not to round it, so do write it all out if you're going to, as much as your calculator will show you. But you could just write the square root of 85, and I'll show you why in a second. I'll show you why now. So we've got the square root of 85 squared plus 11 squared is equal to x squared. Now we want to square this, which means multiply by itself. So the square root of 85 multiplied by the square root of 85, that would just give you 85. And you can try in your calculator, if you do the square root of 85 multiplied by the square root of 85, you're going to get that's equal to 85. So that would just be 85, because the square root of 85 squared is 85. And if you'd done this 9.2195 and so on, and you wrote it out enough, and you done squared, you'd also get that's equal to 85. But if you do round it, this number will be just slightly different. Plus, and then we've got 11 squared. 11 times 11 is 121, and that's equal to x squared. So now we need to add these two together. So 85 plus 121 is equal to 206. So we've got 206 is equal to x squared. And if we just turn that around, we get x squared is equal to 206. This side obviously isn't 206 centimeters. That's the length of this side squared. So we need to square root. So x is equal to the square root of 206. And when we work that out, we get the square root of 206 is equal to 14.3527 and so on centimeters. And the question, did it tell us how many decimal places to give it to? No, I'm going to give it to 3 decimal places. So that'll be 14.353 centimeters to 3 decimal places. And that's it. Okay, let's have a look at our next question. So question number 22. Question number 22 says a frame is made from wire. So we've got this frame made from wire. The frame is a trapezium, and you can see it's a trapezium because we've got this is a right angle and this is a right angle. So the left hand side and the right hand side are parallel to each other, and it's a quadrilateral, so that's a trapezium. And we've been asked to calculate the total length of wire needed to make the frame. So if we start here, we know we're going to need 20 centimeters to get to here, another 15 centimeters, another 13 centimeters, and whatever length this is, and we'd add that all up. So we want to find really the perimeter of the trapezium, and that's going to be the length of wire that we need. So we need to find the length of this side. I'm just going to call that x. Now if you have a look here, we can actually create a right angle triangle, because if you go up here to 13 centimeters and then we go across, we can cut across nice and straight and tidily across, and that would be a right angle at the top here. So if we just go across here from the 13 across there, that'd be a right angle triangle on the top, and it'd be a rectangle beneath, which is 13 centimeters by 15 centimeters, and then this is our right angle triangle at the top, so just cutting it across. So this is a right angle triangle, and we actually know we can easily find two of the sides of that right angle triangle and then use Pythagoras' theorem to find the third. So the base of it is quite easy. If this is 15 centimeters, the length of the base would be 15 centimeters because that's a rectangle. So the opposite sides have got the same length. So that's 15 centimeters there. In terms of the height of the right angle triangle, if this is 13 centimeters here, this is 13 centimeters here. So if you do 20, take away 13, that's equal to 7. So that means the distance from here up to the top would be 7 centimeters. That's from here to here, 7 centimeters, and obviously down would be 13 centimeters. So 20, take away 13 would be the extra height, which is 7 centimeters. So we've now got the length of two of the sides of the right angle triangle. So we can use Pythagoras' theorem to find the third. So let's label our sides. So the right angles here, so the longest side is this x, and we've got our two shorter sides, a and b. So let's write down Pythagoras' theorem, a squared plus b squared equals c squared. So a squared, that's going to be 7 squared, plus b squared, that's going to be 15 squared, is equal to c squared. Let's call that x squared. So 7 squared is 49, plus 15 squared is 225, is equal to x squared. And if we work this out, 49 plus 225 is equal to 274. That's equal to x squared. So the length of this side squared is 274. Let's turn that around. X squared is equal to 274. We now want to find the length of this side, so let's square root. So x is equal to the square root of 274. And if we do the square root of 274, that's equal to 16.5529 and so on centimeters. So that means that x, this distance, is 16.5529 and so on centimeters. And that's fantastic because we were asked to find the total length of wire needed. So that's the length of all of those sides. So it's the perimeter of the trapezium. So we can now do 20 plus 15 plus 13 plus 16.5529 and so on. So let's do that. 20 plus 15 plus 13 plus 16.5529 and so on. And when we do that, we get 20 plus 15 plus 13 plus answer is equal to 64.5529 and so on centimeters. And we've been asked to give our answer to two decimal places. That'll be 64.5. We've got 52, so we're not going to round up. So it'll be 64.55 centimeters. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at our next question, question number 23. So shown below is an equilateral triangle. So we've got this equilateral triangle with a side length of 4 centimeters. I've been asked to calculate the area of the triangle. So we want to find the area of this triangle. Now, actually, there was a previous question further back in this booklet where we found the height of an isosceles triangle. And we're going to use a similar approach to find the height of this equilateral triangle, because to find the area of the triangle, the area is equal to half the base times the height. So we want to do half the base multiplied by the height of the triangle. So we want to find the height of the triangle. So I'm just going to divide it down vertically like so. And it's an equilateral triangle, so we'll have a line of symmetry going down in that direction. We'll actually have 3 lines of symmetry, but we're just going to focus on this one for now. And we're cutting it down vertically like so. Now it's an equilateral triangle, so all the sides have got the same length. So if that's 4 centimeters, this distance here will also be 4 centimeters, and that distance will be 4 centimeters also. And we've cut it down vertically, so if that's 4 centimeters there, and because it's a line of symmetry, that's going to be 2 centimeters from here to here. So we've got this right angle triangle on the right hand side. So because we know two sides, we can use Pythagoras' theorem to find the height of the triangle. And then once we find the height of the triangle, we can do half the base times the height, and that'll give us the area of the equilateral triangle. So let's do that. So let's focus on this right angle triangle on the right hand side here. So we've got our two shorter sides, A and B, and actually that's the height of the triangle. Let's just call that H. And then we've got the longer side of the right angle triangle, that'll be opposite the right angle, so that's our C. So we've got a squared plus b squared equals c squared. And then a is going to be 2, so that's 2 squared, plus b squared, that's the height of the triangle, so it's going to be h squared, is equal to c squared, so it's going to be 4 squared. 2 squared is 4, so we've got 4 plus h squared is equal to 4 squared is 16. And then we want to find out what h is, so we want to get rid of the 4 and then get rid of the squared. So take away 4 and take away 4. So we've got h squared is equal to 12. And then h will be the square root of 12. And the square root of 12 will be 2 root 3 or 3.4641 and so on. And so we now know the height of the triangle is root 12, the square root of 12, or 2 root 3, or 3.4641 and so on centimetres. We can now find the area of the triangle. Actually, let's just label that as 3.4641 and so on centimetres. That's the height of the triangle. So to find the area of the triangle, we need to do half the base times the height. So the area is equal to half multiplied by the base, which is 4, multiplied by the height of the triangle. We could use this 3.461 and so on. You could use the square root of 12. It's up to you. I'm going to do 3.4641 and so on because that's just on my calculator display at the minute. So I'm going to use that as answer. So I'm going to do a half. So I'm going to press the fraction button, a half, or I could type in 0.5 multiplied by 4 multiplied by answer, and that's equal to 6.92820.323 and so on centimetres squared. And that's it. So that's the area for the triangle. So just to recap, we took our equilateral triangle. We knew that if the base is 4 centimetres, the length of this side is 4 centimetres. We considered the line of symmetry, the vertical line of symmetry, and we chopped it into a right angle triangle. That would then be 2 centimetres, and if that's 4 centimetres, we can use Pythagoras' theorem to find the height of the triangle, the height of the equilateral triangle, and then that would be equal to root 12 or 3.4641 and so on. We could then do half the base times the height, so you could just do 2, half the base times by the height, or you could do the base times the height and then divide by 2, or you can type it all in one go like I did, and you'll get an answer of 6.9282 and so on centimetres squared. And let's just round that. Let's round it to 2 decimal places. That'll be 6.93 centimetres squared to 2 decimal places. And that's it. Okay, let's have a look at our next question. Our next question, question number 24, says Rebecca makes a metal frame for a brooch by joining 5 pieces of wire. So she's got 5 pieces of wire. That's A to B, B to C, C to D, D to A, and also from A to C we've got this 1, 2, 3, 4, 5 pieces of wire. The mass of the wire is 0.489 grams per centimetre. So each centimetre of wire has got a mass of 0.489 grams. I've been asked to calculate the mass of the metal frame. So because we know the mass per centimetre, if we can work out the length of all the wire that's used, so then if we work out the length of all that wire, we can then work out the mass of it because we know that each centimetre would have a mass of 0.489 grams. So let's start off by finding the length of AC. So we've got this right angle triangle, and if this is the right angle, the longest side, the hypotenuse is the side opposite. This is our longest side, our C. Let's call it C because A squared plus B squared equals C squared. And then let's label our 2 shorter sides. So let's call this one A and this one B. And you could have called it A and B or B or A. It doesn't actually matter with the 2 shorter sides which are around you label them. So let's substitute our values in to find the length of AC, and we've called that B. So let's substitute our values. So A squared, that's going to be 4 squared, plus B squared, that's, well, just B squared, is equal to C squared, and that's 5 squared. 4 squared is 16, so we've got 16 plus B squared is equal to, and 5 squared, 5 times 5 is 25. Now we want to find out what B is, so we want to get rid of the 16 and then get rid of the squared. So let's take away 16 and take away 16. So on our left hand side, we just have B squared, and on our right hand side, 25 take away 16 is equal to 9. And then, as you just spot on, this is a 3, 4, 5 triangle. So you've got 3 centimetres, 4 centimetres, and 5 centimetres. It's a special right angle triangle. And then we've got B squared is equal to 9. If we want to find out what B is, we want to get rid of the squared. So we want to do B is equal to the square root of 9, and the square root of 9 is 3. So that means the length of AC is 3 centimetres. So that means the distance from A to C is 3 centimetres. That's fantastic because now if we have a look at this triangle on the right hand side, we've got the length of 2 sides, 1.6 and 3 centimetres. We can use Pythagoras' theorem again to find the length of this side, the hypotenuse. So let's change colour of ink. I'm going to change colour to blue, and let's label our sides. So our longest side would be this one, it's opposite the right angle, and the 2 shorter sides would be A and B. So I've labelled this one A and B. It doesn't actually matter which way around we label them A and B as long as they're the shorter sides, and this is the longest one. So let's write down Pythagoras' theorem again. A squared plus B squared is equal to C squared. So A, that's 1.6, so 1.6 squared, plus B squared, that's 3 squared, is equal to C squared. So that's C squared. 1.6 squared, well, 1.6 squared 1.6 squared is equal to 2.56 plus 3 squared is 9, and that's equal to C squared. And then so if we add our 2.56 to 9, it's going to be 11.56, and that's equal to c squared. And just turning those around, we get c squared is equal to 11.56. And the square root of 11.56 is equal to 3.4. So C is equal to 3.4 centimeters. So that means the distance from C to D is 3.4 centimeters. And that's fantastic. We now know the lengths of all 5 pieces of wire that Rebecca uses, and we know the mass per centimeter, so hopefully we'll be able to use that to find the mass of the frame. So let's do that. So let's add together the lengths of those bits of wire. So let's do that. So we've got 3 plus 4 plus 5 plus 1.6 plus 3.4. And when we add those together, we get 3 plus 4 plus 5 plus 1.6 plus 3.4 is equal to 17 centimeters. So Rebecca uses 17 centimeters of wire, and each centimeter has a mass of 0.489 grams. So if we just do 17 multiplied by 0.489 grams, that's going to give us the mass of that wire. So 17 multiplied by 0.489 is equal to 8.313 grams. So that means the mass of the wire that Rebecca uses is 8.313 grams. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 25. So question number 25 says, shown below is a right angle triangle. So we've got our right angle triangle, and it's got the right angle at the top. That means that the hypotenuse, the longest side, would be the side opposite it. In this case, it would be the base. So that's the hypotenuse, the longest side of that right angle triangle. And we've got this circle, and the diameter of the circle is x. And we're told that the perimeter of the triangle is equal to the circumference of the circle. So the distance around the outside of this triangle is equal to the distance around the outside of the circle. And we've been asked to find the diameter of the circle x. So we want to find the diameter of the circle. So to begin with, what we're going to do is we're going to find the perimeter of the triangle. So we need to find the length of this side, so the length of the hypotenuse. So if we find the length of the hypotenuse, we can then add on 9 and 10, and that will give us the perimeter of the triangle. Once we know the perimeter of the triangle, that's equal to the circumference of the circle, and then we can work out the diameter of the circle. So let's start by finding the length of this side of the right angle triangle, the base of it. So it's opposite the right angle, so let's label that C, and that means that the other two sides will be A and B. And remember, it doesn't matter which way around you label those, A and B, as long as they're the two shorter sides. So remember, Pythagoras' theorem is a squared plus b squared equals c squared. So now let's substitute in our values. So a is equal to 9, so we've got 9 squared plus b squared, b is 10, so that's going to be 10 squared, is equal to c squared, the length of the hypotenuse. So 9 squared is equal to 81, and 10 squared is equal to 100. And that's equal to c squared. 81 plus 100, that's going to be 181, and that's equal to c squared. So that means the length of this side squared is 181. So if we square root it, we'll find the length of this side. So c is equal to the square root of 181, and that's equal to 13.4536241 centimeters. So that's the length of that side. It's the length of the base of that triangle. So let's write it beside it. So let's write our 13.4536241 centimeters. So we've got the length of this side, A, which is 9 centimeters. We've got the length of B, which is 10 centimeters, and we've got the length of C, which is 13.4536241, and so on centimeters. Now we want to find the perimeter of the triangle. So if we add those numbers together, we add those values together, we'll find the perimeter of the triangle. And then when we know the perimeter of the triangle, that's equal to the circumference of the circle, and we can work out the diameter. So let's add those together and see what we get. So 9 plus 10 plus 13.453, and so on. And let's see what we get. So we've already got this on our calculator display, so I'm just going to add 19. So add 19 will give us 19 plus the square root of 181, or that's equal to 32.45362405 centimeters. So that's the perimeter of the triangle. Now we're told the perimeter of the triangle is equal to the circumference of the circle. So let's change colour of ink here. Let's change to red. And we know the circumference of the circle is equal to this value here, 32.4536, and so on. So the circumference of a circle is equal to pi times diameter. So that's the formula to find the circumference of a circle. Circumference is pi times diameter. So that means the circumference of the circle is equal to pi times the diameter. Now we know the circumference is equal to 32.4536, and so on. And that's equal to pi multiplied by the diameter of the circle, which is x, so multiplied by x. Now we want to find what the diameter of the circle is, so we don't want this multiplied by pi on this right hand side of the equation. So if we divide both sides of this equation by pi, we'll find the diameter of the circle. So divide by pi and divide by pi. Now, starting off with the right-hand side, we had pi times x. We're dividing by pi to get rid of the multiply by pi, so we'll just be left with x. And on the right-hand side, we've got our 32.4536. That's already on my calculator display. So I'm going to press divide by, and then pi, and then press equals. And that gives us 10.33030938. So that means the diameter of the circle is equal to 10.33030938 centimetres. And let's just round that to 2 decimal places. That'll be 10.33 centimetres to 2 decimal places, and that's it. So let's write that down, 10.33, and that's it. Okay, let's have a look at our last question. Question number 26, and it's a non-calculator question, so I'm just putting away my calculator. And we've been told shown below is a right angle triangle. As you can see, it's a right angle triangle. And we've been asked to work out the length of x, so we want to find the length of this side, and we've been asked to leave our answer as a third. So leaving it as a third means that we're going to leave it with the square root symbol in it. So we're going to be doing this question without a calculator, and we'll find the length of this side, and it should be the square root of something. Okay, so let's label our sides A, B, and C. So C is the hypotenuse, the longest side of the right angle triangle. That's going to be opposite the right angle, so that's our hypotenuse, C. And then our sides A and B, we'll label those A and B, our two shorter sides. And again, remember, it doesn't matter which way around you label those. So let's write down Pythagoras' theorem, A squared plus B squared equals C squared. So that's Pythagoras' theorem. And let's substitute in our values. So A squared, well, A is the square root of 3, so we're going to write down the square root of 3 squared, plus, and then we've got b squared, and that's equal to x, so that's x squared is equal to c squared, and c is equal to 10, so it's going to be 10 squared. Now let's work out what we get here. So we've got the square root of 3 squared. Now if you square root something and then you square it, you'll get what you started with. So for instance, if I had the square root of 16 squared, well, the square root of 16 is 4, and then square root is 16. So if we've got the square root of 3 squared, we're just going to be left with 3, because the square root of 3 multiplied by the square root of 3 would just give us 3. So it's going to be 3 plus, and then we've got x squared, so that's just going to be plus x squared is equal to, and then we've got 10 squared, and 10 squared is 100, so we've got 100. So that means that we've got 3 plus x squared is equal to 100. We want to solve this and find what x is, so we want to get rid of our plus 3, and then we want to get rid of our squared. So let's subtract 3 and subtract 3, so we're going to take 3 away from both sides of our equation. On our left-hand side, we took away 3 to get rid of the plus 3, so we're just going to be left with x squared. And on the right-hand side, we had 100, and we're taking away 3, so it's going to be 97. So we've got the x squared is equal to 97. Now, normally at this point, we'll know this side's not 97 centimetres, it's that side squared is 97, so we need to square root. Now, normally what we would do is we would work out the square root of 97 on our calculator, but this is a non-calculator question. So we're going to write down that x is equal to the square root of 97, and that is our answer, the square root of 97. So that is our third that we're going to leave it as, and that can't be simplified. And if you watch a video on Corbettmaths called Simplifying Thirds, that'll show you how to simplify thirds, but that third cannot be simplified. So the answer would just be the square root of 97, so we're just leaving it as a third. That's something with that square root sign in it. And because it's a non-calculator question, we can't actually work out what the square root of 97 is easily. So let's just write that down, that x is equal to the square root of 97. And that's it. So these have been the video solutions to the Pythagoras practice questions on Corbettmaths. If you need any extra help on Pythagoras, if you go to video number 257, and I think there's another couple of videos on Corbettmaths as well on Pythagoras. So if you go to corbettmaths.com/content, so you scroll down to video number 257, there's a video tutorial there on Pythagoras. And if you have a look at around the videos around that number, you'll also see other Pythagoras videos as well. But in this video, we're focused on the video solutions to the practice questions. I hope you found it useful. If you have found it useful, please like the video and please subscribe to the YouTube channel. Thank you. Cheers. Bye.